Question 1 of January 2025 S1 paper says Jen has one fair four-sided red die and one fair four-sided blue die. The red die has a side numbered 1, 2, 3, and 4. The blue die has sides numbered 1, 3, 5, and 7. The discrete random variable R represents the score from one roll of the red die. The discrete random variable B represents the score from one roll of the blue die. Write down the name of the distribution of R. So since we know that both are fair four-sided blue die, we know that the probability of getting each number will always be the same. Therefore, it's a uniform distribution. Since it says that it's discrete, the answer that we need to give here is that the name of the distribution of R is discrete uniform distribution. In part B, we need to find the probability that the number on the red die is smaller than 3. So smaller than 3, we include only 1 and 2. So we need to find the probability when R is equal to 1 and R is equal to 2. So since all the percentages are equal for each and every one, and there is only 4 possible outcomes, we know that for each outcome the probability is 1/4. So 1/4 plus 1/4 is 2/4, so 1/2. In part C, we need to find the expected value of R and the expected value of B. So to find the expected value when all the percentages are equal and the step between each number is equal, so in this case in both it's equal, because here is +2, +2, +2, and here is +1, +1. So since it's all equal, a trick to do it faster is to find the middle value, and if there's an even number of values, as in this case where there are 4, we just get the 2 middle values and find their average. So in case R, the average will the mean in case R, the expected value will be 2 plus 3 over 2, which is just 2.5, and an expected value of B is 3 plus 5 over 2, which is just 4. Now, showing our working, we need to find the variance of B. We know that the variance is equal to the expected value of B squared minus the expected value of B all to the square. So we know the expected value of B, which is 4. We just need to find the expected value of B squared. How we do that? So we multiply the number of the die squared times by the probability. So in this case it would be 1 squared times 1/4 plus 3 squared times 1/4 plus 5 squared times 1/4 plus 7 squared times 1/4. This gives us an answer of 21. So we just do 21 minus 4 squared, which is 16, and we get that the variance of B is equal to 5. In part E, we are told that Jen rolls each die once, and we need to find the probability when R plus B is smaller or equal to 5. So before we do anything, we can just go ahead and write all the cases where this will be valid. So for dice R, we are told that it has numbers 1, 2, 3, and 4, and dice B has values 1, 2, 1, 3, 5, and 7. we can go ahead and write down the cases where this will be valid. So 1 and 1 will be valid. 1 and 3 will be valid. 1 and 5 will be 6, which is not smaller than 5, so that's not valid. Then 2 and 1 is valid. 2 and 3 is valid. But 2 and 5 is not valid, that's greater than 5. And 3 and 1 is valid. And 4 and 1 is valid. So we've got 6 valid cases where each case has the same probability of happening. So this is like as 1/4 times 1/4. And all that 6 times because we've got 6 different cases. So that's 1/4 times 1/4 times 6. That gives us an answer of 3/8. In part F, we are told that we need to find the probability where r squared is smaller than b. Again, we can find the cases where this is valid. So when we draw 1 from r and 1 from b, 1 squared is equal to 1. So that is not valid because it needs to be small. R squared needs to be smaller than b. So we need to find the cases where this is valid. When we draw 1 from r and 3 from b, that's valid. When we draw 1 from r and 5 from b, that's valid. And 1 from r and 7 from b. When we get 2 from r, it's valid for 5 and for 7 from b. Again, all probabilities are equal, so we've just got 1/4 times 1/4 and all that for 5 cases. So times 5, and we get an answer of 5/16. In part G, we are told that the random variable d is defined as the magnitude of the difference between the score on the red die and the score on the blue die. The table shows the cumulative distribution function of d. Showing your working, we need to find the value of p. So to find p, we need to find the probability when the difference between the two is 4 and add that to 3/4 because this is a cumulative distribution function. So the difference is 4 between the two when we get a 5 from b and a 1 from r, or a 7 from b and a 3 from r. So that's 2 cases. As we said before, all the probabilities are equal. So 1/4 times 2, 1/4, and we've got 2 of these cases. So times that by 2, and that gives us an answer of 1/8. As we said before, we're not done yet because now we need to add the 1/8 to the 3/4, and we get an answer of 7/8. So P is equal to 7/8.